People always ask me, well, how do you grow such big, beautiful plants? And how come your plants are so healthy? And I always tell them they have to forget about growing plants. They've got to focus on growing the soil. So that's what we're going to do today. I know most people, when they want to learn how to garden, they think, well, that's what I need to do is I learn how to grow plants. And I'm just here to tell you that you don't have to grow plants. You just have to grow soil. So learning how to grow soil is what we're going to talk about today. Because if you can grow good soil, then the plants are going to get what they need and everybody's going to be happy. But for now, let's talk about the two different ways that you can actually build soil, okay? What is soil really? We really have to wrap our brains around what soil is, because really most people think that soil is just some solid stuff that holds up plants. They think it's just some inert substrate, just some nothing that is only there like clay or rocks to give roots something to hold on to. Well, nothing could be farther from the truth. The truth is that soil itself is a living, breathing organism. Soil itself is the fertile basis that all good fertility comes from. Plant fertility and nutrition that eventually feeds our bodies. It all comes from that soil. The reason there's so much nutritional problem today is because the topsoils that we're getting our food from are completely depleted of minerals and other good things that would make fully healthy plants. So therefore we don't have fully healthy people. This is one of the things we're trying to correct through soil building, getting good fertility and good soil structure back so we can have healthy plants and healthy lives again. So the two things we need to look at in soil building are the soil composition, what is the soil actually made of, and then fertility. Now we're going to look at fertility a little bit later because it's kind of a more complex subject. But right now let's talk about soil composition. What is it about the makeup of soil that makes for good soil? The two things you need to have in soil are aeration and drainage. You need to have lots of good air spaces in that soil so that the water can come into the soil and move on through it. The roots can grow easily through those air places in the soil, and the roots can drink the water that moves on through. The worst thing is to have compacted soil. Compacted soil is the enemy of good gardening. So if you can remove compaction through increasing your aeration and drainage, then you're going to have happy plants because the roots are going to be able to grow as big as they can. Okay, so now this would be an example of compacted soil. This is soil that gets walked on every day. It hasn't gotten water all summer. It's barely got some weeds growing out of it that can barely survive in there. This soil here, it'd be very difficult for plants to grow in. This is probably the kind of soil you might have in your backyard that you have to improve. So let's take a look at how bad this is. I mean, what I have to do to open up this soil is take a mattock to it. Now if I got to do that to that soil to get down in there this far, imagine what a plant root has to do to dive through this stuff. So as you can see, one essential piece of soil building is a lot of hard work. You got to be able to put steel to soil in order to loosen up compacted soil. Now either you're going to get a machine to do that, like a rototiller or a tractor, or you can do it yourself with a mattock or a pick, or a garden fork, or whatever you have. But at some point, something's got to break up that soil to be able to let the roots go down in there. Now I've got a test that I do to so I can tell whether or not soil is too compacted or not to grow in. I call it the fork test. I take a regular gardening fork and I send it up into the air and I let it fall. And if that fork sticks in the ground, then I know roots can grow through that. But if the fork tines can't go in the ground from that bit of a fall, then they're not going to make it in that ground. Plants aren't going to grow very well. But now check out what happens if you do that in really good soil that has been worked well. Here's a garden bed I worked up yesterday. It has a lot of aeration and a lot of drainage, about a foot down. So I can take my garden fork and let it fall and it goes right in. That bed's ready to plant. So by the time we're done today, you're going to have soil this good that you can grow whatever you need to grow. So the other problem with compacted soil is not only does it not have aeration, there's no air in it, but it doesn't have very good drainage. When you try to put water on it, the water puddles up. I mean, it soaks in a little bit at first, but then the water doesn't soak in. Even where you dig it, or even where you try to add some, you got a puddle of water there. It's going to take a long time for it to soak in. And a lot of times in compacted soil, that water is not going to make it to where it needs to go, which is to the roots of your plants. But now check out what happens with the drainage of a bed that's got really good aeration in it. You put some of that water on there, and it soaks right in. It might puddle up a little bit at first, but most of that bed, even when it's got moisture in it, it's going to be able to absorb that water. That water is going to be able to drain into that bed and go all the way down into the deep root zone so we can have big plants. So plants need water, of course, but they also need air. The roots of plants have to be able to get gases from the atmosphere, and the only way they can do that, being underground, is through the tiny pockets of air that are present in well-aerated soil. So now I want to talk about fertility in the soil. We talked about soil composition, and there's some words that go with that, the tilth of the soil, the crumb structure, the friability. These are different terms that talk about the structural shape that the soil is in, the aeration and the drainage. And we talked all about that, but we didn't talk about fertility. So what is fertility in the soil? If we're building soil, we got to build the fertility in the soil, but what is that fertility exactly? This can be a really overwhelming subject for a lot of people, and I think it creates a lot of unnecessary anxiety. What I'd like to do is just go through the different parts of fertility, soil fertility, real quickly, so that if you want to look into any of those aspects further, you can, but you'll know enough to start. Now, the three kinds of soil fertility would be microbial, organic matter, and mineral. Now, the microbial aspect of soil fertility is kind of the hardest to understand. Scientists really don't know the exact nature of it. Healthy living topsoil has millions of species of bacteria, microscopic organisms, all sorts of mycorrhizae, fungal webbings growing in there. There are so many different organisms and species of fungus and bacteria growing in a good healthy soil that they say there are more organisms in 1 little square centimeter of soil than there are human beings on the planet. So good healthy soil is full of microbial life, and we'll talk more about how to enhance conditions for healthy microbial life when we talk more about composting. But for now, the microbial life of the soil, the invisible microscopic part, we just have to remember that that is critical, and that's the part that gets destroyed by chemical intensive growing, using chemical fertilizers, pesticides, and herbicides. It's the microbial life of the soil, that part of fertility, that suffers the most. So now the mineral part of soil fertility, that's where people get really confused. Now I'm talking about those 3 scary letters, NPK. They stand for nitrogen, phosphorus, and potassium. These are the 3 main chemical nutrients that plants require. Now, it's important to remember that there's no such thing as plant food, okay? I think this is why people get so anxious about the subject, but there is no such thing as plant food. You don't feed plants. Fertilizers for plants are not for the plants. They really ought to be for the soil. I think that the whole concept of feeding plants plant food is a false thought that's been put upon us by fertilizer salespeople, because they want us to buy a lot of fertilizers, and that's what the little blue fertilizer water is for, right? To pump up the plants. Well, when I'm talking about fertilizer, I'm not talking about plant food. In fact, we have to get rid of that whole concept of plant food, just the same way we have to get rid of the idea of growing plants. We grow the soil and the plants get what they want. So we have to feed the soil. So now how do we feed the soil with the things that the plants need? Well, the three basic elements, the nitrogen, the phosphorus, and the potassium, all come from different kinds of soil amendments. Now, the nitrogen in plants is the greenness. When a plant is growing full and green, it's getting plenty of nitrogen out of the soil. The phosphorus is for the flowers and the fruit. And that's how you remember that, because of the F sound. The phosphorus as an element is what helps flowers and fruit develop on a plant. Now the potassium, which is represented by a K in the chemical abbreviation, K stands for potassium. Potassium as an element is really good for stem structure, for root growth. Potatoes and other root crops really need to have plenty of potassium in the soil. Now you get these things in the soil by adding various soil amendments. Some of the different soil amendments you might have heard about might be rock phosphate, which is a powdered form of rock that is high in phosphorus. Green sand is a type of mineral sand that's mined off the coast. It's high in potassium and phosphorus. You have kelp. Dried kelp is wonderful. Ocean plants are full of great minerals and good plant nutrients. All these different types of things, rock phosphate, green sand, all the different organic soil amendments, they can all add great fertility, mineral fertility to the soil. Now we used to have to buy big bags of those organic soil amendments and then test our soils to find out which ones were needed. Nowadays, you can find different products that have all the different soil amendments blended in them to make a nice, simple, easy to apply fertilizer to help the soil grow really nice plants. So in addition to nitrogen, phosphorus, and potassium, plants also need to have a whole set of trace minerals. There's about 50 of them that have to be present in the soil, or else all sorts of chemical reactions can't take place that really have to have really healthy plants. The trace minerals need to be put into soil because, frankly, they've been degraded out of all the topsoil that grows most of our food. They simply don't have the trace minerals there anymore. So you can have chemical fertilizer, add lots of nitrogen and phosphorus and potassium all you want. Those plants aren't going to be healthy plants because they're not going to have the mineral content that they need to have. If you're going to build healthy organic soil, then you've got to add trace minerals somehow. Now what I use to add trace minerals is glacial rock dust. They take glacier rocks and grind them up real small, tiny, tiny powder. And glacial rock dust powder, if you put that in your soil, it's going to release a whole lot of different fertility that otherwise would not become available to your plants. So one of the best things you can add to your soil to make it rich is manure. Good old-fashioned barnyard manure. Now, a lot of barnyard manure is pretty toxic these days, frankly, so you're going to have to be kind of careful about your sources. This is a load of horse manure that I get from a stable of some friends of mine. I know that they don't use a lot of chemicals in their pastures, and I know they don't use heartworm medicine on their horses, because a lot of times heartworm medicine in the horses is going to kill the worms that are in your compost because it goes right through. But aged manure is the most important quality of the manure. You can use horse manure or cow manure or chicken manure or rabbit manure. Don't use dog or cat manure, of course, but all these other barnyard animal manures, they're all fine to use directly into your garden soil if they're aged, if they're old enough, if they've sat around for about a year or so. You don't want to use any fresh manure in your soil because a lot of the ammonia gases that are given off from really fresh manure can burn the roots of tiny little transplants. When fresh manure has too much ammonia smell, it's called too hot. They refer to it as too hot of a manure, and it's not a temperature heat, but it's an ammonia chemical kind of heat. So what you want to do is take any kind of manure that you get and make sure you let it sit for a while. Make sure you let it age, and don't put it into your soil until it's at least 6 months old. better yet, you can take that fresh manure and make compost with it. That's what we're going to be talking about next. But far and away, the very best thing to add to your soil is aged compost that you've made yourself. This is some compost that I made, and this is the best possible stuff to put on your garden. Now we'll talk about how you make compost like this at another session, but for now, this compost here is made up of plant debris from plants that I've grown in the garden that I've mixed in together, horse manure that I've mixed in. I've put in different minerals and fertilizers like we talked about. The compost pile is a great place to introduce all the nutrients to the garden. Of course, if you're just getting started and you want to get a garden growing right away, well then you can add things directly to the soil. But I think the best way is to integrate all your amendments into the compost pile. That way, when you apply the compost onto your garden, you know that the soil's going to get everything that you put in the compost, plus all the microbial activity that the compost has brought to life. Okay, so here's a little bed that I cleared all the old stuff away. I forked up the bed really nice so it's nice and deep and fluffy. We're going to grow something here, but first we've got to build up the soil in it. So we're going to add some things to it and mix them all in. First things we're going to add is our horse manure. You want to spread it out evenly. No more than an inch thick. I'll take some of my compost, spread it on there. Then I'll take some of those fertilizers, some of those organic NPK, mix a little of that in there. And our trace mineral powder, glacial rock dust. Be careful not to breathe this, not good for lungs. Doesn't need very much, just a little trace. Now when you've got all your soil amendments all spread out evenly on your bed, then you take your garden fork and you mix them in with that process called tilthing. The most important thing about adding any soil amendments to any kind of soil is that it becomes evenly mixed. You don't want a pocket of compost here and a little clump of powder here because it hadn't gotten thoroughly mixed. So we covered a lot of ground today. We talked about soil structure, we talked about fertility, we talked a little bit about compost and manure, and we talked about some of the elements that you have to pay attention to have really fertile soil. Once you know how to grow the soil, then all your plants are going to grow just fine. Thanks for joining me.